Good evening, everyone. Can you hear me? Hello. This works. Cool. So this talk is about streaming data. My name is Frank. I would actually like to ask you a favor. Can I take a picture? The GDPR version would be just hide your face if you say no. It's for my boss who always says, if you traveled to Greece, like how was the beach, and did more than 3 or 4 people show up. So this is the streaming data I want to talk about, and I also want to talk about the concept of a data lakehouse, and that's the official title, streaming data on the lakehouse. I work for Databricks. Who knows Databricks? Just like, oh my God, I've never seen so many hands. I think you all have a really good education, or you all work with Azure Cloud. That's the 2 reasons typically why people know it. So we like to call ourselves the data analytics and AI company. Actually, I just had a chat in front of the door of the room, and I said, like, our CTO, he's sometimes putting comments on my documents. He's literally the guy who wrote Spark. And one of our principal engineers, Michael, he's actually the guy who wrote Delta Life tables. This is what I want to focus on here a little bit more. And it's also MLflow that is coming from Databricks, which is another open source project. As I said, my name is Frank. This is my Twitter handle. I'm based in Munich, so I spend my time in the mountains, drinking beer, eating pretzels. I used to work for AWS. I recovered, and then I changed to Databricks. Right, let me kick this off with a question. And since you all know Databricks, I think you all have an opinion on this. What do you like most about Apache Spark? Oh, if you think back, like when you started, what was the first wow moment that you had? For me, it was like, I'm old. I have my history with, Perl and Python and all these languages where you try to load files and make meaning out of those files, like JSON files or like CSV files. And seeing Spark for me for the first time, that you could just read any number of JSON files from a directory and then apply all this data frame magic, like, selecting the customers that drive a Audi or BMW or Mercedes or whatever car, and then show this list across all these files. I thought, like, wow, this is so good. And then if you look at the second box, that you could just apply SQL for the same thing, is like, wow, this is amazing, isn't it? And if you have a managed notebook, let's say in Databricks or probably in other environments too, you could just switch from one notebook cell to the other one. And if you're like not such a good SQL person like me, I'm very opportunistic. I like to take sometimes the SQL version and sometimes the data frame version. This is amazing. This is the environment I like to work with. So this was the first wow moment for me when I worked with Spark. What we tend to forget, and this is actually even going more back to my past, I used to work in high performance computing. This is what the people do that kind of, try to tell you about how the climate will be in 50 years or in 100 years. So what they do is they do message passing. They send messages around to other processors, and then they make them compute something, and then they collect the messages. And they do this manually. Sometimes they do this with a little bit of compilers. But at the end, it's a lot of manual orchestration. And then if you send a message with data to some remote instance and it's not coming back, you have to take care about this and all this. If you write a SQL statement or data frame statement in Spark, it's just executed automatically in parallel. And that's also something we tend to forget, especially if people take a course, in one of these online courses. They don't even see this parallel execution. But I think it's something amazing and something that is kind of the more modern way of doing this high performance computing. And let's not forget the initial roots of Spark is you would just run it on a cluster of PCs that you would buy from Aldi or I don't know, the equivalent of. Do you have Aldi here? Like one of these cheap department stores where you buy the cheap PCs. Anyway, but this Parallelization is happening. It goes through a logical optimizer and through a physical optimizer. And then if you choose like a company like Databricks, there's many more things happening behind the curtains. Then, remember I showed you the streaming data. Years ago, I did a tutorial about Kafka, and that was the time I was working for AWS. I don't know what happened, but this tutorial got 50,000 clicks now, and every 10 days or so, I get a comment on YouTube or an email, and someone says, "Hey, Frank, can you tell me how to write a client for Kafka?" And I thought, hey, why did I do this tutorial? Now people send me emails and ask me the same things. So the other thing, the cool thing about Spark is that you can read a JSON file almost the same way as read from a stream. It could be a socket stream, it could be Kafka, it could be Kinesis. And the only thing you basically do is you replace the read with read stream, and then you select format, Kafka, Kinesis, socket, whatever. And you have your streaming, kickstarted your streaming application. So the short version for these emails that I get, like, hey, Frank, how do you write a Kafka client, could be spark.readstream.format Kafka. But obviously they say, can you teach me how to do that in Java? So it's all about stream processing. I think this is going to be more and more important. Actually, at Databricks, we believe this will be the future for almost everything. And I believe most of you pretty well understand the difference between batch and stream processing. Batch is always this two-step process where you accumulate data on some storage. And then very often on a Friday afternoon, you run your ingest, your ETL process. And I have a lot of friends who were working in these jobs, like data engineers running ETL processes on Friday afternoon. And then typically we were planning on Friday afternoon to go for a beer, like at 6 o'clock or 5 o'clock. Well, 6 o'clock actually. And then they called me and said, hey, Frank, the ETL job, it crashed in the middle. Now I need to clean up everything. It takes more than an hour. And I just figure out why it's not running. And I need to run it again. We need to skip the beer. So if you're in this position, you have to skip the beer. It's a good opportunity to look into streaming processing, where you process the data as it arrives. I think that's maybe one of the most compelling reasons. And there are strings after this talk, so I'm super excited that we're still filling up a room. Technical advantages. Very, very often, our customers or other people talk to us about, yeah, low latency, and I don't need the low latency. I would love to have lower latency for my dashboards. But streaming is not always about lower latency. It's actually the more intuitive and the more natural way of implementing such, let's call it, application. So you get the lower latency, obviously, if you don't queue up all your data, batch up all your data the whole week and then run it on a Friday. You get better fault tolerance because it's easier to get fault tolerance. And it's also getting cheaper because you don't have to plan your systems for this Friday peak. You can have like a very small instance size continuously running. So at the end, you get better compute utilization, and it comes with a lot of advantages. But it also comes with a lot of misconceptions. The first one I already told you, it's not always about low latency. It could be low latency. Sometimes people call it real time, and then I always discuss and kind of fight with our marketing people. They like to call it real time. I say, look, real time is something that happens in the ABS of your car, or in the traction control of your motorbike, or in your heart pacemaker of your grandfather or whatever. But it's, it's guaranteed execution times, sub-milliseconds, and that's probably not what you should expect from Spark. Because it's running on a JVM, it's doing garbage collections, etc., etc. So it's not only about low latency. And the other one is this, I like to call it CAP theorem. Do you know the CAP theorem? Good people are sitting in the front row always saying yes. It's actually the thing that you remember from computer science that you study again if you apply for a job at Google, because they will ask you for this. I don't know if we ask engineers about the CAP theorem. So if you want to apply for a job at Databricks, I don't know, I can't tell you. My shoemaker, the guy who's actually having a shop 20 meters away from where I live in Munich, he has a sign, and this sign says, I know you want it cheap, You want it quick and you want good quality. Pick any two of those. So he understood his CAP theorem, and the CAP theorem for streaming data is accuracy, cost, and latency. And as I said, if I start talking about streaming data, people say, yeah, latency, latency, latency. But it's very often not about latency. I don't have the percentage, but if you ask like a lot of customers, which two of those three would you pick? The majority of them would not pick latency. If you're a business customer, you want to get stuff done rather quickly, but you typically don't care about 60 seconds or 90 seconds latency. You want it cheap. If you reduce the cost from, let's say, 100 million to 40 million, and you tell your boss, look, I just saved you 60 million, whatever, dollars or euros, you will get a big hug. If you tell him I reduced the latency from 6 seconds to 4 seconds, he says, does it cost me more? Maybe it might cost you more because you need to, throw more compute at it to get better latency. Okay, so the short summary, and sometimes our marketing team even disagrees, is it's the programming paradigm, it's not the latency. And one of the core frameworks, you've almost all raised your hands, I'm still so surprised, is Spark Structured Streaming. Michael Armbrost wrote it, and he's actually the guy who said, well, we had Spark Structured Streaming for a long while, and now it's time to improve this, which is a bit the core of the second part of the presentation. So Spark Structured Streaming, scalable, fault-tolerant streaming engine. You can use it with SQL. We have another project going on right now. It's an open source project. It's a project, not a product. It's called Project Lightspeed. Karthik, one of my colleagues, he's working on predictable low latencies. If you do Spark Structured Streaming, you have to write checkpoints. And very often these days, they're written in a synchronous way. But he's a super clever engineer, super clever guy. I think he was a professor for computer science. So he knows all the theory. And he figured out very clever ways of doing this in a predictable, asynchronous way that is still reliable. It's called Project Lightspeed. We're going to have the Data and AI Summit soon. That's kind of something I just want to insert here. It's end of June. It's free if you participate online. If you come to San Francisco and participate in person, say hello to me. And Karthik is going to talk about Project Lightspeed. It's 1 year old. We have a lot of improvements that go back to open source Spark. So streaming ETL, it kind of looks like this. You have a source, you do this read stream from Kafka, and then you do a transformation, you do a select, you do a cast, you cast some JSON parameters, you write it back to another stream, and then you trigger it like within every 30 seconds or so. So it comes with the benefits that it's a unified API. I told you can read from a Kafka stream almost the same way as reading a directory of JSON files. It's high throughput. That's what people want. They want the throughput, and it's exactly one semantics, and it's a rich connector ecosystem. So it's not, first of all, about latency. And then the title of this talk is Streaming Data on the Data Lakehouse. And I assume that the Lakehouse concept is kind of new to many people here. It's actually something that is easily explained with this data maturity curve. The data maturity curve starts on the left. This is your data warehouse. So the data warehouse is actually something that is not getting your typically hugs from your manager. If you do cool stuff, it will be on the right side of this curve. This is where all the AI and the machine learning happens. And let's think about the LLM models that we see these days. They always start from a data lake. They always read from an S3 bucket, and then they do magic things. At the same time, people who work with data lakes will tell you, well, but then we lose the format, we don't have the schemas, and we lose a lot of the things, a lot of quality of service that we had in the data warehouse space. So actually, people want to move to the right of this curve, but you cannot give up the left side of this curve. If you look into this in more detail, it's also two paradigms, colliding. One is the SQL world with the schemas of the data warehouse. The other one is what I already told you. It's Python notebooks, where you don't have a schema, where you have your data frame. So it's two different teams, two different skill sets. If you come from the governance and security side, it's on one side, you need these crazy, complicated IAM rules for AWS buckets, and then you need different things for your GCP objects. And on the other side, you need to govern tables and schemas, etc. So these two worlds are not working together. It's almost like 2 years at Databricks. At the beginning of my time at Databricks, I did an interview with a colleague from AWS. She wrote a book about data science on AWS. And I said, do you really believe that this is kind of true, that those two systems you copy over data, they don't work together? I said, you're the expert in machine learning. Tell me, when was the last time you were running a machine learning application, notebook, algorithm based on a data warehouse, based on your Redshift? And she said, like, you know what? I never do this. Sometimes I have data in Redshift and then I export it. So I'll take it from here and I put it into an S3 bucket and then I run it from a notebook from an S3 bucket. So these two worlds seem not to work together too well. So what we kind of kicked off and built is this concept of a lakehouse, which is the best of a data lake and a data warehouse. And the idea is it should be simple. So it should unify both workloads that you have in one platform. So it's one platform only. It should be open, based on open standards and open source. Already told you a little bit about that. And it should be multi-cloud. It should just run on any cloud. So people say, okay, but how is this working? Well, the core of this lakehouse paradigm or approach is a thin open source layer. It's called Delta Lake. It's also the guy who did the Spark Structured Streaming engine. He wrote Delta Lake. And the Delta Lake or Delta I/O gives you back the quality of service that you have from your data warehouse. So it kind of takes your data lake and gives you the quality of service that you have from a data warehouse. So the short answer, what is a lakehouse? It's this thin layer of open source that converts your data lake into the lakehouse, which then gives you both approaches, the data lake approach and the data warehouse approach. So you get your asset transactions back. Remember the guy, this friend of mine, who calls me and says, look, we can't go for beer because it broke in the middle. No asset transactions. You can get them back with Delta Lake. It's published. There was a paper published about the Lakehouse initiative. It's actually something, we're always proud. We kicked this off. But now if you Google for Lakehouse, you will find results from AWS. They talk about the Lakehouse. Oracle is talking about the Lakehouse. Google is talking about the Lakehouse. This web-based data warehouse company, I forgot the name, they're talking about the Lakehouse. Everyone is talking about the Lakehouse concept. At the beginning, all these analyst companies, like Gartner and IDC, they said, interesting what you're doing, but we're not really sure if this is a new category. And now they also talk about the Lakehouse, which is kind of the now we have it moment. Whoops, that was the power supply. It's still all up and running. Delta Lake, it's open source, 8 million downloads per month. It comes with this whole, or should I say, bunch of adapters for everything, for Trino, Fling, Presto, Kafka, Beam, whatever, you name it, we have an adapter for it. If you want to start with Delta Lake, like on a command line level, all you do is PySpark minus package, and you add the Delta Lake package. It will then pull the package from the internet, and you have your PySpark shell. It's just working. If you say, okay, but then I have a different format. Yeah, you have a different format, but the format gives you all this quality of service, things like asset transaction. You read your JSON files from my first example, you write them as a Delta table, and done. If you try, I talked about all the magic that Spark brings you and how amazing this is and all the wow moments. But if you would go just one step further without Delta Lake or some similar technology, and you read in all these JSON files, you create them, you create a table, create or replace temporary view customers, and then you do an update on them, it will break. So this is how far the magic of Spark goes if you want to update something and not just read. If you have a proper table format like Delta, you can do it. You can update. You can actually do much more with Delta, and that's the SQL. It's just to make it shorter, to get it on one slide, I put it in SQL notation. You can update, you can upsert, you can actually time travel. You can update a table. You can say, update something where customer ID is that, and then you forget the where customer ID. You update the whole table. You overwrite email addresses for all your 20,000 or 20 million customers in the table because you forgot the where clause. And then you say time travel, go back to the last version, and you have your last version. So another cool thing that I like to ask people with their data lakes is, how do you do updates, and what happens if something goes wrong? Can you roll back? We can clone, we have a table history, we can define what should be co-located, and because we keep this version, we can also compact the stored location. And now people say, okay, I get it. You come from this big data space, and now you have this table format. But again, this will never work with my data warehouse workload. It's just not made for this. This is the misconception that we were dealing with for a long time. Actually, it does work. Long story. It's implemented in a serverless way. The next thing we did is we wrote Photon. Photon is the Spark API rewritten in C++. So it's a vectorized C++ execution engine that goes really well with modern processors. What you see here is these are Databricks versions. I think now we have 13, and this is the improvement in speed that we saw. And then when we released Photon, it made this big jump. So it's worth it. There's a benchmark with 100 terabyte of data that we kind of redefined. We won this benchmark, and Databricks Data Warehouse is number one. So it does work. That's the short version. And streaming, well, the short answer, well, streaming, you can still do your old Spark Structured Streaming, like read stream. I'm going to show you something like this in a small demo in just a minute. Do you know Gregor Hope? See some people nodding. I think he's half German. He used to work for a while in Germany, but he was a long time at Google. He wrote this book about, enterprise integration patterns. He's always good for a quote. So if you see him on Twitter, it's usually good to screenshot that because you might need that for a PowerPoint slide. So he said, you should create abstractions and not illusions. So if you have everything that I just told you, like Spark and Spark Structured Streaming and managed notebooks that do SQL and Python and data frames, at the same time you have this data warehouse performance, what else would you want? And the answer is, well, can we simplify this even more? And there's a couple of things that we have, and this is, to be very honest, this is now the product part, which is not open sourced. We open source a lot. It often depends on customer demand. One thing is Autoloader. Autoloader is a streaming data source, and it kind of simplifies data ingestion in a way that you just throw a file into an S3 bucket, and it will then be automatically ingested. Now, you probably think, well, I could build this with on AWS. You have an S3 bucket. You need a notification service like SNS. You need a queuing system like SQS. And you could build this, and you need to make it scalable and fault tolerant. And as always, you could do it manually, but should you? I mean, the easy way it works in Spark is you just say cloud files. That's the keyword for Autoloader. You give it a folder name, and then whatever happens in this folder name is ingested in a streaming way. Streaming way means we keep the state. It's done incrementally. If you stop it and restart it, it will restart from where it stopped. So it's a lot of magic happening behind the curtains. And we just had an onboarding event, and some people joined Databricks from AWS. And I showed them this. I said, look, this is how we do it. And he says, yeah, Frank, but you're not telling the people all the SNS and SQS and whatever you need to do to make this work. And I said, look, the cool thing is I'm not doing it. The platform is doing it for me, and this is how it should be. So that's the cool thing, building abstractions, not illusions. And the second thing I want to point out, and hey, this is again Autoloader, how it looks in SQL. So if you say, create me a streaming table, whatever name, and read everything from Autoloader in this directory. That's all you need. So if you specify something similar to Autoloader on the back of an envelope, if you ask me this, like if we go for drinks now, I would probably write something like this, from directory, file type, and then just make it happen in ingest in a streaming way. And this is exactly what Autoloader does. And Delta Live Tables is kind of the thing that comes after Spark Structured Streaming. It takes away a lot of the complexity of Spark Structured Streaming. You don't need checkpointing. You don't need to manage your state. It becomes much easier. It's working in SQL. Basically, the way it works is you create a pipeline of tables. So the first one is called raw data, and the second one is called clean data. And the clean data table is reading from the raw data table. So if you connect them in this way, you can create a DAG, and then you can execute the whole DAG as a pipeline. There is a built-in orchestrator in the Lakehouse, which basically does orchestration. So this is the matrix view of tasks that we're running. This is the control flow orchestration that you see. What we do is we orchestrate your notebooks, we orchestrate Python wheels, Python code, DBT, if you want to use DBT for transformations, DLT, the one that I'm talking about here. It's orchestrating anything on the Lakehouse. The cool thing is it's completely serverless. There is no backend. You don't need to set up something. You don't need to configure the software. It's just there, and all you do is it's the next one. You click on new task, you define the task type, you say I want to schedule a notebook, and then you have all the beauty, and it's run in the background with a pretty good availability. I think we're at 4.5 nines right now. All right, let me skip this, and let me show you two things. The first thing, and this is just because of the time. How much time do I have? 10 minutes, that's good. So the first demo I show you on slides, I apologize, it's slides, but I've done it many times. That was me at Daytona I Summit last year. I built a system that everyone has built once. You ingest data from Twitter. You work with the Twitter stream. I took the data from Twitter. I put it in an S3 bucket because everyone does this. This is the data lake approach. Not just dump it in an S3 bucket and then someone else should process it. How would you process it? Two important things. One is DBFS. It's the Databricks file system, a file system on top of S3. You can just read it as a file, the blob in S3. And then we have this DLT, Delta Live Tables, and it's pure SQL. You create the pipelines. The pipeline uses Autoloader to ingest the file. It's purely written in SQL. It then cleans up the tweets, because if you ingest the data from Twitter, you get like 44 different columns, and you have a lot of rows with people tweeting in languages that you probably don't understand. What I wanted to do is I wanted to have a Hugging Face transformer model for the sentiment analysis. And I've done the sentiment analysis. And then if you draw such a word cloud, it looks like this. So that was like ingesting tweets that contain Data I Summit last year. And that's how it looks like. So people talk about the summit, about DLT. You see words like the positive ones, like excited, like rocks, like cool stuff. So it worked pretty well. I was a bit scared that people would tweet things that seem to look good and that show up in this word cloud, but nobody did. I didn't pre-announce the demo, so it all worked pretty well. Okay, now this is how the ingestion looks like. Autoloader. You say, hey, Frank, that was a cool demo for San Francisco. All you do is like one line for ingestion. You give it the S3 bucket, which is abstracted as a directory. You say it's JSON files, and that's it. And this was my first table, a streaming table. We like to use this architectural pattern because you see this brass now. We call it Battalion Architecture, like the medallions you get at the Olympics, like bronze, silver, and gold. This is how it connects to Athens, and that was not planned. So the medallion pattern says you ingest to browse, you keep the raw data, then you improve the data, you drop lines, you drop columns. What does it say? 10 more minutes? Okay, cool. You drop lines, you drop columns, you do joins, and then at the end you go from bronze to silver to gold. Every step you improve the data quality. And then the gold tables are the tables that you would expose downstreams for your Tableau, for your BI dashboards, whatever. Okay, this is why it's called bronze ingestion. The next step would be to go from bronze to silver, all using SQL. Now, the real demo that I want to show you is, it's a Corona topic. I always tell my colleagues, please don't talk about Corona anymore. Everyone is sick about this topic. When Corona started in Germany, this is actually when it was right in the middle, but when it started, we had 2 patches on the whole map with Corona outbreaks because of 2 different groups of equally stupid people. One group, they went to Austria for skiing, and they had after-ski parties where you hug and kiss people and do whatever, I don't know. And the other group was, they were celebrating Carnival. And it was at the beginning, but everyone knew what was going to happen. And the after-ski party and the Carnival people, they ignored it. We had 2 red patches here. I should have taken an earlier picture, but I don't have. And then clever scientists said, look, we want to detect these patches early. So what if we could measure fever across all the 80 million people in Germany? And then, well, you can't measure fever across 80 million people in Germany. So they said, no, we can't measure fever, but what we can do is we can measure the heart rate of those people. Now, how do you give people heart rate measurements? The answer is you're all walking around with these heart rate fitness wrist bands. So there was an application that said, would you like to donate your resting heart rate so we can evaluate it? And that's the outcome. So if you are Corona positive and your heart rate goes up, even before the test, the heart rate goes up. So this system could detect potentially an outbreak even before people get tested. That's the theoretical story that I was telling, does the heart rate go up and then it goes down? I was telling this I did this talk 3 times, different versions. I was always super careful, and then this happened. That's me. Not going to talk about the details, but this is where I was still going for a drink with friends. This is where I felt bad. I felt worse. I told my manager, no, I can still work. This is when I called in sick. This is when I was really sick. And this is when I thought, everyone was saying, are you still sick? I said, yeah, I still feel horrible. And when this curve was down, my resting heart rate measured with my Fitbit, I was feeling okay. So it really works. I cannot tap into the real data. It's health data, blah, blah, blah. But I built a simulator for this, and this was the streaming data you've seen at the beginning. So my thought was let's collect this data in a Kafka topic, and then let's read from this Kafka topic. Let's go through delta life tables using the delta life table syntax, and then let's use Spark Structured Streaming to see if the average heart rate is going up or not. And this is what I want to show you. Let's start here. That's the pipeline. That's the DLT pipeline. If I zoom in, you see I didn't follow the naming like bronze, silver, gold, but this is where I ingest the Kafka events. This is where I process them. And this is where I have the cleansed events. And at the end, I'm creating a statistics table. So before the data is coming here, it's actually generated. I was playing around. It's generated in a separate notebook. If you work with Kafka, how would you generate test data? So people use API services like Mockaroo. I started with this. Then I always had this extra service with extra keys. They have a rate limit, I think, for the free version. So my colleague said, why don't you rewrite it with a notebook? And I thought I don't know if I want to do this. I did it, and I tell you, I was super happy doing this. Let me zoom in. My 2 suggestions for you is, one is use Faker. So if you have something like you want an IP4 address for fake Kafka data, use the Python library Faker. But not everything is done with Faker really well. So my second favorite way of doing things is just using random.choices. You give it a list of choices that you want to have. Like I told you, I needed to kind of fake the IoT data. So I said, well, it's Apple Watches, Garmin, Fitbit, and undefined. And this is the probability. And it actually goes even further. You can go to choices. And I said, for the pulse, that I want to measure, I assume it's like a normal distribution with this, and it's centered around this pulse value. I think it's like 85 or so. Actually, yeah, I don't tell you now what I do. So if the pipeline is running, it's a streaming pipeline. So the super cool thing is, let me click this away. Let me zoom in here. It was running all the time while I was speaking. When I triggered this before I started, it was ingesting 2,800. If I click on start, it's a pipeline that is triggered manually. I could run it continuously. If I click on start, it should ingest more data. Actually, all the data that was created between the last run and now. So this takes a couple of seconds. It's initializing, setting up the tables. But then we should see the same graph again. Let me zoom in. And here you see the events that are happening in the data pipeline. It's setting up, it's creating the tables, it's checking stuff. All these events basically go back to a Delta table. So if you want to build your own monitoring system, I'm not saying you should, but if you wanted, for the data pipeline, you could go back to these Delta tables and run the data pipeline. Okay, now, whoops. Look at this, 8,200. So it ingested another 8,200. In total, there will be the 2,600 from the beginning plus the 8,200 from now. And if I rerun the whole pipeline and say refresh, it should be over 10,000. So I could refresh all the time. I get everything. But remember this friend of mine who couldn't come for the Friday beer? He would probably want this incremental way of just ingesting what was left over. This is 2 minutes. 3. I'm pretending not to see this really well. Promised them drinks and ice cream to give me another 5 minutes, but it doesn't work here. Okay. Well, that's the data pipeline that we're going to see again. Let's look at this. You see it's still working. Let's scroll here. It should show up like, I think, 10 or 11,000. Look at this. Isn't that brilliant? 11,000. I told you. It's a 2,800 I had from the beginning when I triggered the thing before my talk, and then the 8,000 that you saw. In total, it's 11,000 for the full refresh. Now, looking at the data analytics, what I'm doing is the classic Spark Structured Streaming. I say, the last table, it's the BPM cleansed table. And I say, read from this table, group it by BPM, that's the heart rate, make me windows, which are 1 minute long, and then average the BPM in an ascending way. And it kind of looks like this. So is the average heart rate going up? Yes. Does it mean people have more and more fever? Yes. Are we at big risk? No, because it's just simulated data. That's actually what I wanted to show you. Happy to answer questions in the last 2 minutes. And since we have a full room now, I'll take another picture of you, if you don't. Do you want to do a thumbs up? Thank you. That's for my manager. You're going to save my job. Going to get you all free drinks afterwards. Any questions, please? Sure.
So hi, awesome presentation, thanks. You mentioned when you combine the data warehouse and the data lake, types about ACID transactions, and that got me maybe kicked off my fantasy, let's say, imagination.
Yeah.
How much do these transactions expand? Are they only for ingesting data into the lake, or could you actually go further and, for example, do machine learning training or streaming things and then cancel the transaction?
Now it's for simple asset transactions. So it's for operations, which sounds a bit underwhelming. But if you look at what guarantees you get from S3, where you couldn't even update a bucket, but you only, if you update a bucket in S3, what you get is a new version. And then if you do this and I do this at the same time, this is the ACID transactions that you get from Delta Lake. And the fun thing is you can figure it out how this is working for S3, but it will be different again for GCP, and it will be different again for the ADLS and in Azure. And the Delta Lake is covering all this. So it gives you a layer where you can just say update, and your update is typically just done, it's committed, or it's rolled back. So this is what I mean. What we have is this whole connection. What I'm opening here is actually the SQL editor. So people say, okay, I haven't shown you this now, but people say, but where's the data warehouse part? Data warehouse people, they want an SQL editor. They want, syntax highlighting. They want completion of table names and stuff. So if I do a select star from, this is the first table, the Kafka events, and I execute it, this is the SQL view that is going through Photon, which is the C++ rewritten Spark API, and that is returning here the first 50 Spark events. And this is then also what you can use and create your dashboards and all these graphics around. So this is the data warehouse view on the same data. But the cool thing is it's one and only data set that is in S3, so you get the cheap storage costs, you get the high availability, the crazy good durability. You don't have to manage it. Delta Lake makes it ACID compliant, and then with the Lakehouse approach, you get the SQL view, you get the data science view that I was showing you. Or the other thing that we have is the machine learning part, which is then the managed ML flow, which I wasn't talking about. I think we will be talking more about ML flow, and ML flow is now managing also the Hugging Face transformers. We now have the first courses to build your own large language model. We built Dolly, which is a large language model based on a 1-year-old open source model, which was not good. It was not good in interaction, so you couldn't ask it questions, but it had a lot of knowledge. So what we did is we built this, interaction layer. I think GPT, when they started, they had like 13,000 question answers to teach it the interaction to answer a chat question. What we did is we had 15,000. So an ex-colleague of mine, he just chatted to me. He said, how did you do that? How did you implement 15,000 question answer pairs? I said, well, we have 5,500 people at Databricks. So do the math. Everyone did like 3. And then the guy was chatting me again. He said, was this a voluntary thing or were you forced to do it? I said, no, come on, this is gaming. You tell people the more you submit, the higher are your chances to win something. And that's how we did it. So we have our own open source language model. It's called Dolly. You can get it for free. It's not meant to compete with GPT, but it's pretty good. You can ask it questions. Like I asked it a question. I said, look, I have a colleague who comes for the first time in his life to Munich. It's a sunny day. What would you suggest him to do? And it talks about, go to English Garden, which is one of our biggest, nicest park, and then tell your colleague to go to Hofbräuhaus, which is where you get the traditional food. I feel like, this is not bad. All right, thanks very much for being here. You've been an amazing audience. If you have any questions, I'll be around.